My name is Karen Daly and I teach mathematics at DKIT, a third level college in Ireland. This video was produced to further assist my first year computing students with their mathematical studies. At the end of this tutorial, you will be able to convert a binary, octal or hexadecimal number to decimal. Enjoy! The first step in understanding how to do this conversion is to review our knowledge of a decimal number. Let's consider the decimal number 1593.674. Because this number is base 10, each position within the number represents a power of 10, just as follows. 3 is in the units, or the 10 to the 0 position. 9 is in the tens position, 10 to the power of 1. 5 is in the hundredths position, 10 to the power of 2. 1 is in the thousands position, 10 to the power of 3. And if we move to the right of the decimal point, the 6 is in the 1/10ths position, or 10 to the power of -1. 7 is in the 100ths position, or 10 to the power of -2. And lastly, the 4 is in the 1000ths position, or 10 to the power of -3. Let me recall for you powers of 10. 10 to the power of 3 is equal to 10 by 10 by 10, which is 1000. 10 to the power of 2 is 10 multiplied by 10, which is 100. 10 to the power of 1, anything to the power of 1 is just itself, is 10. 10 to the power of 0, by definition, any number to the power of 0 is 1. 10 to the power of -1 is equal to 1 over 10, and that's equal to 0.1. 10 to the power of -2 is equal to 1 over 10 squared, which is equal to 1 over 100, or 0.01. And lastly, 10 to the power of -3, and squash it in here, is equal to 0.001. So I can write this number 1593.674 as 1 multiplied by 10 to the power of 3, which is the 1000, added to 5 multiplied by 10 to the power of 2, which is the 500, added to 9 multiplied by 10 to the power of 1, which is the 90, plus 3 multiplied by 10 to the power of 0, which is the 3 units, plus 6 multiplied by 10 to the power of -1, which are the 6/10ths, plus 7 multiplied by 10 to the power of -2, plus, and lastly, 4 multiplied by 10 to the power of -3. This idea can now be used to convert our binary, octal and hexadecimal numbers to decimal. Let's consider the following example. Convert 10111.01 base 2 to decimal. This is a binary number, so each position within the number holds a power of 2. So, moving to the left of the binary point, we have 2 to the power of 0. Next we have 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4. And moving to the right of the fractional point, we have 2 to the power of -1, 2 to the power of -2, and 2 to the power of -3. Let me recall for you powers of 2. I won't write them all down, but I'll just recall a few for you. 2 to the power of 4 is 2 multiplied by itself 4 times. So it's 2 by 2 by 2 by 2. And if you multiply all them 2's together, you get the value 16. 2 to the power of 0, by definition, again, any number to the power of 0 is equal to 1. If we look at 2 to the power of -1, 2 to the power of -1 is equal to 1 over 2, and 1 over 2 is equal to 0.5. If we look at 2 to the power of -2, 2 to the power of -2 is 1 over 2 squared, 1 over 2 squared is 1 over 4, and 1 over 4 is 0.25. So now we can write 10111.011 base 2 is equal to 1 multiplied by 2 to the power 4 plus 0 multiplied by 2 to the power of 3 plus 1 multiplied by 2 to the power of 2 plus 1 multiplied by 2 to the power of 1 plus 1 multiplied by 2 to the power of 0 plus 0 multiplied by 2 to the minus 1 plus 1 multiplied by 2 to the power of minus 2, and lastly plus 1 multiplied by 2 to the minus 3. Now doing this sum we get 1 by 2 to the 4 is 1 by 16, so it's 16, plus 0 by 2 to the 3, 0 by anything is 0, plus 1 by 2 to the 2, which is 1 by 4, so it's 4, plus 1 by 2 to the 1, 1 by 2 is 2, 1 by 2 to the 0, 2 to the 0 is 1, so it's plus 1, 0 by 2 to the minus 1 is 0, 1 by 2 to the minus 2, 2 to the minus 2 we saw is 0.25, so it's 0.25, and lastly 1 by 2 to the minus 3, 2 to the power minus 3 is 1 over 8, and 1 over 8 is 0.125. And adding all these together, we get 23.375. So the decimal, or the binary number 10111.011 base 2 is equal to 23.375 in decimal. What I'd like you to do now is to pause the tutorial, try this exercise yourself, and when you're done, come back to me and I'll go through the solution with you. Here we have the binary number we want to convert, and if we put in our powers of 2, to the left of the fractional point we have 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and lastly 2 to the power of 4. And to the right of the fractional point we have 2 to the power of minus 1, 2 to the power of minus 2, 2 to the power of minus 3, and lastly 2 to the power of minus 4. Now multiplying this out, we have 11011.1011 base 2 is equal to 1 multiplied by 2 to the power of 4 plus 1 multiplied by 2 to the power of 3 plus 0 multiplied by 2 to the power of 2 plus 1 multiplied by 2 to the power of 1 plus 1 multiplied by 2 to the 0 plus 1 multiplied by 2 to the minus 1 plus 0 multiplied by 2 to the power of minus 2 plus 1 multiplied by 2 to the minus 3, and lastly plus 1 multiplied by 2 to the power of minus 4. Working this out, what we get is that's equal to 1 by 2 to the power of 4 is 16, 1 by 2 to the 3 is 8, plus 0 by 2 to the 2 is 0, plus 1 by 2 to the 1 is 2, plus 1 by 2 to the 0 is 1, plus 1 by 2 to the minus 1 is 0.5, plus 0 by 2 to the minus 2 is 0, 1 by 2 to the minus 3 is 0.125, and lastly 1 by 2 to the minus 4. You can work it out using the power button on your calculator, 2 to the power of minus 4, or else you can write it as 1 over 2 to the 4, which is 1 over 16, and the answer is 0.0625. And adding all these numbers together, we get the value 27.6875. So the binary number 11011.1011 base 2 is equal to the decimal number 27.6875. Now we can extend this idea to convert an octal number to decimal. Let's consider the example. Convert 237.81 base 8 to decimal. Now let's write in the powers of 8. To the left of the fractional point, we have 8 to the power of 0. Then we have 8 to the power of 1. And lastly, 8 to the power of 2. To the right of the fractional point, we have 8 to the power of minus 1. And lastly again, 8 to the power of minus 2. Now, converting this to decimal, we have that 237.61 base 8 is equal to, well, it's equal to 2 multiplied by 8 to the power of 2 plus 3 multiplied by 8 to the power of 1 plus 7 multiplied by 8 to the power of 0 plus 6 multiplied by 8 to the power of minus 1, and lastly plus 1 multiplied by 8 to the power of minus 2. Now, working this out, we have 2 multiplied by 8 squared is 2 multiplied by 64, and that's equal to 128, plus 3 multiplied by 8 is 24, plus 7 multiplied by 8 to the 0 is 7 by 1, which is 7, plus 6 multiplied by 8 to the minus 1. 8 to the power of minus 1 is 1 divided by 8, which is equal to 0.125. And if you multiply 6 by 0.125, what you get is 0.75. 0.75. And lastly, if you work out 8 to the power of minus 2, you can use the power button on your calculator, the y to the power of x button, or else what you can do is 8 to the power of minus 2 is 1 over 8 squared, which is 1 over 64, and 1 divided by 64 is 0.015625. And when we add all of these together, we get the number 159.765625. So 237.61 base 8 is equal to 159.65625 in decimal. Now, what I'd like you to do is to pause the video again and try this exercise. Convert 437.021 base 8 to decimal. And when you're finished, turn the video back on again and I'll go through the solution with you. Now, if we write in our powers of 8, we have to the left of the fractional point 8 to the power of 0, then we have 8 to the power of 1, and lastly 8 to the power of 2. And then to the right of it, we have 8 to the power of minus 1, 8 to the power of minus 2, and lastly 8 to the power of minus 3. And writing 437.021 base 8 as a decimal number, we have that it is 4 multiplied by 8 to the power of 2 plus 3 multiplied by 8 to the power of 1 plus 7 multiplied by 8 to the power of 0 plus 0 multiplied by 8 to the minus 1 plus 2 multiplied by 8 to the power of minus 2, and lastly 1 multiplied by 8 to the power of minus 3. And working this out, we have 4 multiplied by 8 squared. 8 squared is 64. 4 64s is 256. Plus 3 8s are 24. Plus 7 1s are 7. Plus 0 by 8 to the minus 1 is going to give me 0. Plus 2 by 8 to the power of minus 2. 8 to the power of minus 2, we saw before, is 0.015625. And if we multiply that by 2, what we'll get is 0.03125 plus. Now the last multiplication is 1 by 8 to the power of minus 3. You can do that directly on your calculator using your power button, y to the power of x, so you'll have 8 to the power of minus 3, or else you can work out 1 divided by 8 cubed, and either way you're going to get the answer 0.001953125. And when you add all of this up, what you get is 287.033 2031. So 437.021 base 8 in decimal is 287.0332031. Now let's proceed to the last part of this tutorial and convert a hexadecimal number to decimal. Let's do the example. Convert 23a.4d base 16 to decimal. Now let's write in our powers of 16. To the left of the fractional point we have 16 to the power of 0, then we have 16 to the power of 1, and lastly we have 16 to the power of 2. To the right of the fractional point we have 16 to the power of minus 1, and lastly 16 to the power of minus 2. Over here, let me remind you of the decimal equivalent of the hexadecimal numbers A through to F. So A, B, C, D, E and F. Well, A has a value 10 or 10, B has a value 11, C 12, D 13, E 14 and lastly F 15. So to find the decimal equivalent of 23a.4d we have it's equal to 2 multiplied by 16 to the power of 2 plus 3 multiplied by 16 to the power of 1 plus, now the next value is a, and rather than a, because I'm going to have to do this as a calculation, I'm going to write down the decimal equivalent of a, which is 10. So it's 10 multiplied by 16 to the power of 0 plus 4 multiplied by 16 to the power of minus 1, and lastly again d. D has a decimal value 13, so I'm going to write down the last multiplication as 13 multiplied by 16 to the power of minus 2. When I work this out, what I get is 2 multiplied by 16 squared. 16 squared is 256. Multiplied by 2, I get 512. Plus 3 16s are 48. Plus 10 by 16 to the 0 is 10 by 1, and 10 by 1 is 10. Plus 4 by 16 to the power of minus 1, which turns out to be 0.25. And lastly, 13 by 16 to the power of minus 2. Again, 16 to the power of minus 2, you can either work it out using the power button on your calculator, or else divide 1 by 16 squared and you'll get the value also. Then multiply it by 13 and the answer will turn out to be 0.05078,125. Now adding all of these together, what I get is 570.3007813. So my conversion is that 23a.4d base 16 is equal to the decimal number 570.3007813. Now what I'd like you to do is to pause the tutorial and try this exercise yourself. Convert FB 6.008 base 16 to decimal, and when you're finished turn the tutorial back on and I'll go through the solution with you. Writing in the powers of 16, to the left of the fractional point we have 16 to the power of 0, 16 to the power of 1 and 16 to the power of 2. To the right of the fractional point we have 16 to the minus 1, 16 to the power of minus 2 and lastly 16 to the power of minus 3. Writing out the solution to this, we have FB 6.008 base 16 is equal to, first we have F, and F in decimal is 15, so I'm going to write down 15 multiplied by 16 squared plus B, and B in decimal is 11, so 11 multiplied by 16 to the power of 1 plus 6 multiplied by 16 to the power of 0 plus 0 multiplied by 16 to the power of minus 1 plus 0 multiplied by 16 to the power of minus 2, plus lastly 8 multiplied by 16 to the power of minus 3. And working all the multiplications out, I get 15 by 16 squared is 3840, plus 11 by 16 is 176, plus 6 by 1 is just 6, plus 0, plus lastly 8 by 16 to the power of minus 3, and that turns out to be 0.001953125. And adding all these together, I get 4022.00195 and 125 is written there as well. Your calculator may not show these last three digits, and that's okay. So the answer to the problem is that FB 6.008 in hexadecimal is equal to, in decimal, 4,922.001953125.